Okay, so number 5, what we're going to do is use the Ka to find the pH of the equivalents. Right? That's what it's asking you to do. I wrote this question. I like this question. It's tough. All right? You start with AHA. We go up. You have gradual slight increase in pH. All of a sudden, right? And we reach the equivalence point. Now, what they're saying is, okay, that's not at pH 7. Why is it not at pH 7? Because what's left in the beaker? You made Ha into Ah. True?
Yes.
Okay. You made Ha into Ah. Okay. Now Ah, what's Ah going to do? Ah is a base. Only thing in there, in that beaker right now, is Ah and water. True? All right. So the Ah says, hey, I see a water. What am I going to do to a water?
Take the H.
What?
Take an H.
Take an H. Make Ha. Am I still on screen?
Yep. Yes.
Okay. So make a Ha. Make a Ha and leave behind an OH. True?
Mm-hmm.
Now this should look familiar. This equation should look very, very familiar. It's the Kb equation. True?
Mm-hmm.
Okay. Base reacts with water to make an acid and hydroxide. So we have a Kb expression for that, yes? True? Okay. So if we have the Kb expression for that, and we know roughly the concentration of Ah, what are these two going to be? How are they going to compare? There was just Ah and water makes Ha and hydroxide. For every Ah and water that makes a Ha and hydroxide, I get a Ha and a hydroxide. So for every Ha, I get a hydroxide. So what's the Ha to hydroxide ratio? 1 to 1. So I want to find the pH. That's X and X. Can I work my way from the OHs to the H's to the pH? Yes? Okay. The only problem with this is this. You're adding water here. All through here and here and here, you're adding water. True? You're pouring in solution, you're pouring some water to rinse it, you're using a lot of water. All right? So you can know the moles of Ah pretty well. The liters of solution is a little tougher. You know the moles because you know how much Ha you put in. True? And you also know the moles of hydroxide that you added to kill it. So you know the moles of Ah. The liters is a little tougher to find. You just got to spitball it. You just got to guess. Because you don't know exactly how much water was in it. But you know you didn't overflow the beaker, so you know you're less than 250. You can kind of say it was about 100. It was about 75, you know. That's the best we can do with that one. All right? So just to recap. You're asked to use the Ka to find the pH. At the equivalence, you know there's just Ah. Ah reacts with the water to make Ha and hydroxide, which is going to make our pH a little bit higher than 7. All right? Not pH 7, it's going to be higher than 7. If I have a Ka, can I find the Kb for its conjugate base? Sure. We can guess this. It's not going to be perfect, but we can guess this to some extent. These are X and X, and we got one equation. And then, of course, once you've got the OH minuses, you can either go to the H pluses, to the pH, or you're going to go to the POH, and you're going to go to the pH. Okay? So that's number 5 on the lab. Hopefully that's helpful.